Hey guys, welcome to this webinar that is recorded after the original live stream. The live stream recording apparently had some technical issues and could not be uploaded, so here's a second attempt at uploading this. A little bit of intro about myself. My name is Vittesh Patel. I have worked in the industry for over 10 years. I worked for a company called Screenworks NEP in North America for roughly about 9.5 years or so, and then I ventured off on my own, started freelance. Today we're going to be looking at pixel mapping versus scaling. Majority of my job has been video broadcast engineering, and then moved on to LED screen engineering, working on larger festivals such as EDCs and Tomorrow World and a lot of Insomniac events up in Northern California, which consists of mostly raves. A lot of these raves, as well as like WrestleMania and all that stuff, utilizes something called pixel mapping. And what it means of pixel mapping is a relatively new term. A lot of foreigners still have a hard time understanding the whole pixel mapping concept. And we're going to go dig into that portion of things and take a look at pixel mapping versus scaling and how it's used, when it's used, and all that good stuff. So let's jump right into it. Let me turn on a presentation here for you guys. So pixel mapping versus scaling, what are the main differences? So pixel mapping is basically mapping every pixel of your output signal, whether it may be your computer, DVD player, or any sort of a digital player that's supplying the signal to actual LED screen. And they all have a specified resolutions, such as 1920 by 1080 being HD resolution. If in more than likely cases, your LED screen is not going to be 1920 by 1080 pixels exactly. So you could utilize scaling, but then there's a couple of different aspects in scaling, as well as if you're scaling out of proportion, in which case your circle on the image will look like oval on the LED screen. So when we're looking at pixel mapping, let's focus on that first. It's going to be one-to-one pixel map. So if your LED screen is, let's say, 1920 pixels wide by 1080 pixels tall, and if you're supplying a 1920 by 1080 signal, then it will be pixel mapped. If you are altering that resolution, let's say your input resolution is 1280 by 720, and your LED screen is still 1920 by 1080, you are going to have to scale that. And then within scaling, there's the aspect scaling and the free scaling. And aspect scaling is basically while maintaining your aspect ratio. So if your signal coming in is 1920 1080, it is 16 by 9 aspect ratio. And if your LED screen is not 16 by 9 aspect ratio screen, then you're going to have to do free scaling, in which case you're going to manipulate the image, and it's probably not going to look good because it's going to be squeezed. You might make some faces stretched out, you might make them squeezed in. While in aspect scaling, you will keep the aspect ratio and just scale it up or scale it down to fit your LED screen. Here's a good example of one-to-one pixel mapping done to all the LED screens, except where you see the live camera, where we are showing the artist. This was obviously scaled because that LED screen was not in a right aspect ratio. However, we maintain the aspect ratio for scaling using something called Barco E2 or NovaStar's newer processors like a Nova Pro Ultra HD Junior or Ultra HD. Those will be able to scale in while maintaining your aspect ratios and scale it on a different layers. So here's a really good example of when you should use aspect scaling. And you're losing a lot of image obviously on the right and left side of it, and you're only showing the center where the artist is performing. Here's an example of stretch scaling, and you can see the original picture of the face versus scaled to on a free scaling poster or something. It's not gonna look good. And we often get these videos or photos from LED manufacturers. If you're getting email blasted from factories in China or around the world that manufacture LED screens, in more than likely cases, they don't pay attention to what they're showing on the LED screen. They just have some DVD or video that they have acquired, and then they'll just display that on the screen that they've built for aging test or for a customer to show what type of products that they make. And then they just put on scaling that doesn't really match the aspect ratio of the LED screen that they've built, and it just does not look good. Here's a perfect example of pixel mapping. So this is a WrestleMania a couple years back in New Orleans that we did, and you can see every LED screen, like the red area all the way in the back. On the back side, the little diamond looking screens, those are 25mm LED screen. The goggles and the clown hat on the top, those are all 7mm LED screens. And try and match all of that with the content. The best way to do it is pixel mapping. And as you can see, there's multiple rasters, like on the top sections. Each one of the points is getting 3 different rasters, and where those areas will be located in the rasters is done by pixel mapping. So we would create a template, give out this template to the client. Client will then hire somebody that will create custom content for this, and they will have to know where each one of piece of that content needs to be displayed in order for us to show it as a full product. And you can see this in the next picture right here. But the signal that's being delivered to us is completely broken up in different pieces, and you can see this goggles right here, goggles top stage right or goggles bottom stage right. Those are 1920 by 800 pixel sections, and these tiles were 80 by 80 pixels. It's a Row MC7 LED screen, which is 80 by 80 pixels, 600 by 600 millimeters in size. And you can see that it's 800 pixels tall, so we're doing 10 tiles on one raster, and then a 10 tiles on the bottom raster. So 2 completely separate outputs from a computer, such as a media server as a Hippo or D3 or something like that. And you can see how it's combining to where you don't even see the seam in between. So why pixel map LED screens, and what are the benefits? Well, let's take a look at that. It avoids distorting content for sure. Stretching face or body or a presenter, body of presenter or an artist is definitely a no-no. You don't ever want to stretch anything that is not intended to be stretched. Even logos. I have seen over and over again so many times that people don't maintain the aspect ratios on logos. It does not look good. It looks very unprofessional. Better management of the screens for text, content creators, and playback servers. This is particularly important when you are stepping into a professional arena of LED screens where you have more than one LED screen, let's say on a job site or on one stage. How do you deliver the content to it? How would somebody make a content of that LED screen without having an actual pixel map template? Creating pixel map template makes all of these things streamlined, brings everybody onto the same page, and it just creates a much better ecosystem for everybody to work on. So if you've noticed how on the raves such as EDC or something, a VJ's video junkies would change every hour. Every hour there's a new set, and there's somebody else that brings on their own computer with their own content, and we have to connect them to LED walls. We usually have 0 seconds to switch them over, It is literally instant changeover from one person to the next. There's never a blackout moment. So in order to make sure that everyone gets exact information that is needed to work on it, create a pixel templates. When used correctly, it can create realistic perspective of a 3D environment. This is another thing that a lot of people fail to see, is when you're creating this massive stages that look amazingly awesome with the depth of field and stuff, the LED screen is one element that makes everything flat if not used correctly. But if you pixel map it, if your content creator has that pixel map and the relation to the stage, they're much more likely to create a 3D content that adds that depth of field that is needed to make that event look even more mind-blowing than it already is. And we'll look at some examples of that later on. Here's one of the examples. These are all flat LED screens with a little bit of deco added to front of that. And you can see like all the 3D content that they've created to match on every LED screen that's exactly to the size of the LED screen. So if they were to put that, let's say all the way stage left picture is a baby with umbilical cord still attached, floating around. If you were to put that in some other screen, it would not look good because you're not going to be able to see that full picture, or you're going to have to scale it differently or whatever. So by giving them pixel templates for pixel mapping the LED screen, you will enable them to become even more creative. Know when to pixel map and know when to scale. Knowing when to scale or pixel map is a huge thing. First step to knowing this thing is when to use what. Knowing when to use aspect scale versus letterboxing, and when to use free scaling. In my opinion, free scale should almost never be used. However, it's there, and almost on all the NovaStar VX6S, VX4S, Nova Pro Ultra HD, and all those other processors available with the scaler built into it, you have a function called auto scale. Now, auto scale is a great feature. However, it's a free scaling feature. As soon as you hit auto scale, it takes whatever signal coming in to whatever signal that's going out, and it will not look good in most cases. Is it simple? Yes, but it should not be used in live events. If you were to take 16:9 screen or 16:9 signal, camera signal that's coming in, and then let's say they decided to make a portrait screens on your stage, how would you scale that over? Take 16:9 video and scale it on a column of screen. It is going to be super hard to see anything on that, and we'll take a look at an example of that. You might want to use aspect scaling at that point, and then stretch that signal top to bottom fill, and then cut out everything left to right. And then letterboxing should be used when you have a horizontal screen that's not really displaying everything from in a 16:9. When you squeeze that in, you're going to have a letterbox on the side, meaning you'll have a black bars on two sides of the screen. Knowing when to pixel map, if you have more than one LED screen that's different size, different shape, use a pixel map. It's always going to be your best bet. So here's one of the example of aspect scaling. So this is 16:9 signal coming in. The screens were not 16:9. You can see the artist standing in the middle. We're displaying on the two sides. And these are IMAX screens, meaning a camera signal that's coming into us. And we just displayed that in 16:9. The screen is actually much bigger than that, and you'll see right here on the next image of Lady Gaga. So this is from a festival called Coachella here in North or South California, and you can see the large display of screen. These are both same exact stages. You are just not seeing rest of the screen on the top image, as that's what artists wanted. They wanted to see the full image of 16 by 9 on the LED wall. And that's what we had to do using, again, Barco E2 switcher, which is now possible using Nova Pro Ultra HD Junior with multiple layers of windows. And bottom picture, you can see we've still maintained 16 by 9 aspect ratio and scaled it up to fill top to bottom and cut off a lot of image on side to side, because that LED screen is, again, not 16 by 9. Here's another example of portrait screens. Top, you can see the pixel map template, and this is how we test it normally. If it's pixel map screens, we would throw up our pixel maps templates and check to make sure every pixel to pixel is exactly what we are seeing on the LED screens. And the bottom picture is where you can see the content. On the stage screens, obviously there's a different content, different situations that they're going throughout the show. On the side screens, it's portrait screens. So here's where they've used aspect scaling top to bottom and cut off side to side. Now, how to do pixel map? Let's take a look at that example. Here's a small example of LED screens. We have multiple different products, and these are all from ROE. So you have CB8 products in the middle, Vanish product creating a border around it that are Vanish 25mm screens, and MC7 on top of that. So here's how I made my template. And this was done on a 3840 by 2160 pixel map. So it's a 4K raster. Normally you want to try and stick to regular size rasters like 1920, 1080, or 3840 by 2160. Sometimes you can go into weird resolutions, custom resolutions, and even though it will work in most cases, if you're going to flip through multiple people's playback servers and you're going to be attaching them in a short period of time, I would suggest keeping standard stuff because it always works. The custom resolutions may work with some video cards, may not work with the others. So just be careful on that. And you can see right here, our Vanish screens and our stage left, stage right screens, or whatever, are much bigger in pixel pitch because they are 8mm screens. The stage left Vanish, stage right Vanish, and on stage Vanish, physically they're the same size. However, they're not same pixel size because they're 25mm screen, meaning the panel sizes in pixels are much smaller. Again, let's take a look at this again. So you can see on the, let's say focus on the stage right LED screens. You have a stage right row Vanish 25, which is bigger than the row CB8 screen that's underneath it. However, in a pixel map, it doesn't matter because pixel map CB8 has more pixels than 25. This 25mm screen is only 48 by 48 pixels versus CB8 is 86 by 86. So that's going to change quite a bit. Then right on top of the pixel mapping templates, we create data diagrams that are automatically made in most cases, such as this one, which also helps us to give this out to our LED technicians so they know exactly how each screen needs to be wired. And then this is how we would exactly program the LED screen. So that way everyone is on the same page. As you can see, the engineer can focus on making sure that the screens are programmed and pixel mapped the way they're supposed to be. The LED technicians can program or wire their screens exactly how they're supposed to be, label all the cables, going to the processors and such. So now let's take a look at this. Map the screen to the processor exactly as your template, and this is what you get. This is one of the stages we've done Dreamfest in San Francisco last year. And you can see the Vanish 25 is a blow-through product, which is see-through product, all the way around the actual CB8 product. And that's it for the presentation. However, we are going to look at how to exactly pixel map this. So let me show you guys that. This is the file that we were looking at. So if you wanted to do drawing or the mapping of that, here's one processor connected to the screen. And the processor I have connected is a VX4S, which is not going to let me do 16 ports on it. However, we'll try to do as much as we can. So go into screen configuration. Go to I'm going to go ahead and load my file. So in my case, I've created 7 screens, as you can see here. The way to add multiple screens is from quantity of LED screen and click configure there. So on the first screen, I've left my coordinates at 0, 576. And if we were to zoom this out, let me open up a pixel map actually. Right here. So 0, 576 is right here on the stage right LED wall. And we are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 cabinets wide. Going back into my NovaStar, and you can see it's 12 wide by 11 tall. Each panel is 72 by 144 pixels. And you can see port 1, port 2, port 3, just like how we have here on port 1, port 2, and port 3. And we have done this for all 7 of the screens. I will make this link available so you guys can pull up this example file and play with it if you want to. And each one of the screen, if you go through it, you'll have a coordinates, exact screen sizes, and the panel count, pixel count for each panel. So right here you can see the border now on one of the vanish screens. You're gonna have 48 by 48 pixels, and you can see I've added in blanks right here by clicking on set blank. If you don't know how to do that, you must do all the blanks that you're not using. And we've only done 2 cabinet border all the way around the actual LED screen. And the pixel count is 48 by 48. Now this is a question I get a lot, is can we use multiple products on the same processor? Yes, you can. You can even use multiple products on the same home run, meaning on the same port. You just have to type in exact pixel count of each panel, and if you're pixel mapping everything, you can do this all day long. Screen 5, screen 6, and screen 7 was 80 by 80 pixels, since that was MC7 panels. And that's how you would, once you send this to the screen, it'll take over, map everything out for you exactly where you've set each one of the screen's coordinations to be. And you can see the XY right here on the last screen is 440 and 0. If we were to look at our pixel map, 440 and 0 right here, that's the top banner screen. And once you map that out, it should look exactly as intended on the pixel maps. Let's see. Here's how the signals are coming into me. And you can see on the top LED monitors. And this is how it's going out to the actual LED screen. So again, this is how it's being delivered to me from the media server. And if you've seen the pixel map, you know it was exactly that. So you have stage right vanish, on stage vanish, and stage left vanish here, plus these 3 screens down here with the top header. If we go back to that right here, take a look at this monitor, and that will make sense. And that's how exactly it's mapped to the LED walls. And this is a multi-viewer of the Barco E2 with some experimental project in my hand there with the buttons. We'll also go ahead and take a look at one more example of this. I do have a small LED screen set up right here in the house, in my office, so might not be the prettiest thing, but I can show you how it works. I'll go ahead and log in with the password admin. Let me try and reconnect, find the processor again. There it is. So here's my 3 panels I have. I have one blank. I only have 3 panels. This is programmed all on a one port from the LED screen. Port 1 starting here on the top, going to the bottom, going over. Now, there's multiple ways to program this screen, and I will show you why we use different ways. So when you're pixel mapping the screens, the things can change on the job site, obviously. And that's why it's better to keep it separate. Right here I have example 1. So here's a screen that we're going to focus on. Let me zoom it in for you guys. So this is 2.6 millimeter screen, only 3 cabinets. I have screen 1 and screen 2. So if I was to map it the way it is right now, and you will be able to see it on the So this are right now they're both together. You can see it's 192 pixels wide, and then the other panel starts at 192. So it's fine if you were to just program it as what I have here and send that to the screen. But now what happens if you had to move this LED screen further out because your content is bleeding onto the screen too that's not supposed to be showing there? So then what you might want to do is, let's take a look at the second example of this. Right here. So if I wanted to displace the screen 2 to show this area of the screen without having to change anything, the better way to map this screen would be to separate out the 2 screens right here. Rather than doing 1 screen, do 2 screens. So okay, we're just gonna do 1 column, 2 rows. We'll start from top to bottom. Create a second screen, and using still port 1, we're going to change our pixel count to 192 by 192. And as you can see, the receiving card number is 3 on here, so it's still wiring on the same port 1. And my offset coordinates now could be 300, and 0. And if I was to send this to the screen, all of a sudden now that's going to show a different location for the screen. And I'll put up a pictures here in this place so that way you can see exactly what's going on the screen itself. And if we were to go back to pixel map 1, which was at 192, again you can just go back in your screen configuration, change the coordinates of this to 192, and without having to change anything else, all of a sudden your display of the screen is going to be to that location. And that's a really easy way to do pixel mapping. To create pixel map templates, this question came up a lot during the actual webinar. We have a software called Pixel Perfect LED. It's made by Red Dot Logics. You can find it on www.reddotlogics.com/ppp. It is made for Windows and PC now. Windows and Mac now. Up until now, the older version was only made for Mac. The newer version works with Mac and PC. You cannot buy it yet. However, we'll give you a 3-month free trial. If you wish to try it out, go to that website link and You'll see tutorial videos. I really urge you to watch one of the tutorial videos so you can know exactly what it's going to do for you. If it adds value to your production, go ahead and get it. If not, there's other resources that do similar things out there. However, it's impossible to do multiple screens with wiring layout and such through some of the other softwares that are available out there. I have been using Pixel Perfect Pro for past several years, and it has been rock solid for us. Of course, we make the software, so you can be your own judge with a 3-month free trial. And that's it. If you guys have any questions, go ahead and post it on this video link, and I'll try and reach out to you guys. Thank you.